Complex Numbers by Michaela Keeney. Real versus imaginary numbers. We've always learned real numbers such as 0 or 2 or 0.156 or pi. But now we are being introduced to what imaginary numbers. Imaginary numbers are like I or negative I or 2I, and those are what we see as imaginary numbers. Now when we see the imaginary numbers come together to form complex numbers. Now when we combine both real and imaginary numbers, that is when we get complex numbers. Complex numbers are very often used by the symbol z. So we have z equals. Now we have to combine both a real number, we'll say 3, plus a complex number, we'll say 7i. These numbers that we have can never be added together because you can't combine a real number with an imaginary. Therefore, these are known to us as our complex numbers. Now when we begin solving, we will sometimes find imaginary numbers. We will know we will find I when we have negative inside a square root. For example, we know that I equals negative 1. So, when we have a square root of negative 1, we do our regular factoring out. So we do 18 divided by 2 is 9. Then 9 divided by 3 is 3. But this ends up being positive. We have to take out this negative 1. Therefore, when we solve the problem, we get 3i, the square root of 2. We get the 3 from our 2 3's right here and our 2 that has been left inside the square root. And we discovered this negative 1. And we know I is negative 1. Therefore, you put it all together, you end up getting 3i, the square root of 2. For us to solve another type of problem where we are multiplying two complex numbers together, we still do our regular distributing. So we're going to distribute the 3 to the 3, the 3 to the 5, 1 first. We'll start there. 3 times 3 is 9. And then 3 times negative 5 is negative 15i. Then we're going to do our 5's. We have 5 times 3i. So it's going to be plus 15i. And then we have one more distributing to the 5, negative 5. Therefore, we get negative 25. But we have to remember to multiply our i's together too, which gets us I squared. If we combine like terms as far as we can, we end up exiting out both our 5's because they cancel each other out. So we're left with 9 minus 25i squared. Going back to our rule where I equals negative 1, we can apply that to our equation. Therefore, we have negative 25 times negative 1 equals, and when a negative times a negative, we get a positive, so 25. So we have 9 plus 25 equals 34, and that's our end answer. Now say, if we were to have a problem where we have an imaginary number squared. So we have a 2i that is being squared. When we square it, this is also 2i times 2i. Therefore, we have to multiply the 2's also. So 2 squared is going to be 4. And then we have to square our I. This is where we have to recognize our I squared. I squared equals -1. So we have 4 times -1. Our end answer will be -4. That is all back due to the fact that I squared equals -1. Now say we have a complex number that is being multiplied by another complex number. So we have 125i times -15i equals blank. We first multiply all our variables together, 125 times -15 and I times I. So 125 times -15, we end up doing all our distributing and multiplying, and we get -1975. So we have -1975, and then we have our I squared. Therefore, this leads into our -1. So if we have a -1, because this is, as we know, -1, and we multiply it times a negative number, we get a positive number. So we end up getting 1,975 as our final answer. Now let's start with a much greater difficulty of a problem. We're going to be dividing our equations now. So we're going to have 4 plus 2i divided by 3 minus I. We never want to have an I on the denominator. So in order to get that from the bottom, we're going to multiply both the top and the bottom by 3 plus I. That's going to be able to get rid of this negative I from the bottom of the equation. Now we're going to have to FOIL these, and it'll be a much harder equation. So we're going to have 4 times 3 is 12, and then 4 times I is 4i, and then we're going to have to do 2i times 3, which is 6i, and 2i times I, which gets us 2i squared. Now we do the same thing for the bottom, and we're going to have 3 times 3, which is 9, 3 times I, which is positive 3i, and we're going to do negative I times 3, which is negative 3i, and then we're going to have a negative I squared. As you notice, we have an immediate cancellation of these two because they cancel each other out. Then we also see we have an I squared. We're now able to simplify this equation as greatly as we can. So we're going to see it to become 12, and we see that we have 2 matching variables, so we can add those together. So 4 plus 6 is 10i, and then plus 2i squared. We notice that there is an I squared. As soon as we see an I squared, we recognize it's a -1. So we do 2 times -1. Then we're going to divide that by 9, and we see that the 3's have already canceled out. And we do it minus another flag, we see an I squared. We just add in a -1. So even farther simplifying that, we go to 12 plus 10i minus 2 divided by 9 plus 1, or we can simplify that even farther, so we can just go straight to 9 plus 1 is 10. Now from here we can completely simplify our equation. So we have a 12 and a negative 2, and if we add those together we get a 10 plus 10i divided by 10. As we see, both of these can be divided by 10, which equals 1 plus I. And therefore, that is our final answer. Now, I hope you fully understand what complex numbers do and how you're able to solve them.